Today, we're going to be creating this sci-fi loop. It's mostly based off of geometry nodes, a few shaders, and a few other tricks here and there. We'll be going step by step, so definitely stay tuned. In our default scene, we're not going to delete the default cube. Instead, we're going to click here and drag to create a new window and change the type to geometry node editor. Now we're going to click new to create a new geometry node tree, and we're going to go ahead and just zoom in and delete the group input. Now we're going to create this in 3 layers. The first layer is going to be a torus. So we're going to search for a curved circle, and then we're going to convert the curved circle to a mesh using a curve to mesh. And then we're going to also duplicate the curved circle, which is going to go into the profile curve. So let's plug the curve into the curve and this curve into the profile curve and place the mesh into the group output. So right now we get this donut shape, and we can go ahead and change the radius of this to 10 so that we get a larger radius shape. We can go ahead and bump up the resolution to something like 50 and also reduce the resolution here down to something like 16 because this is going to be a wireframe. To convert this into a wireframe, we're going to search for a mesh to curve, and we're going to just place that in here, and then again search for this curve to mesh node, or just duplicate it with Shift D and place it over here. And for the profile curve, take another curved circle, Shift D, and just plug it in, just like that. But now we're going to have to change the radius to something really small like 0.01. In fact, you could make it 0.02 if you feel like. Now that we have our wireframe, we can go ahead and start off with the second part, which are all the cubes that are going to lie on the wireframe. So let's just take this, and for neatness sake, Ctrl J to create a frame, hit N to open the side panel if it's not already open, go to the node and just label this as wireframe. Now let's grab this, move it up, and then start off with the squares. So let's just search for a join geometry node and just place that right over here so that we can see all the cubes come in as well. So now let's search for a cube primitive, place that right here, and we want to instance these cubes onto the torus that we've built over here. So remember that the output of this was a torus. So let's take that output and convert that to points. So let's just search for a distribute points on faces over here, and then take the output of this mesh and just place that there so that now we have a lot of points distributed on this torus. Now on the points, we have to instance this cube. So let's search for an instance on points node. And once we search for the instance on point node, plug the points into the points and the cube into the instances. And the output of this can go into the join geometry node. So now we see all of the different cubes that we have, but they're all scaled way too large. So in order to fix that and give each of them a random scale, we're just going to search for a random value node, and then we're going to change the parameters of min to 0.01 and max to 0.2 and plug the value into the scale. So let's just take a look at what it looks like. I feel like the density of cubes could be a bit higher, or else the size of the cubes could be made a bit larger. But we'll deal with that after we place the camera. So let's place the camera now. Let's take this camera, Alt G to clear location, Alt R to clear rotation, and we're going to create a camera rig. In order to do that, we're going to hit Shift A and search for an empty and choose the empty cube. Of course, it could be any shape, but I prefer the cube for this particular action. Now let's take our camera, Shift select the empty, and then hit Ctrl P to set parent to the object. So now our empty is the parent of the camera. Now let's Shift A, curve, and search for a Bezier circle and just scale it up by 10 so that it goes right into the center of our torus. So if we just hit 7 on the numpad, we should be able to see that it goes through the center. You can see the slight overlaps happening over there. Now we can take our empty, go to the object constraints, add an object constraint of follow path. And for the target, let's just select our Bezier circle. Now you'll notice that the camera is pointed down, and in order to fix that, we want to make sure that we check follow curve and we make the up axis as Y and the forward axis as Z or Z. So that way our camera is now pointed forwards. So if we hit 0 on our numpad, we go into the camera view. Now we can select our camera and make changes over here. So let's go to the object data properties or the camera properties and change the focal length to something like 18 so that we see a lot more. And along with that, go to viewport display and just increase passport out all the way to 1. So clearly, there's 2 things that I'd like to change with the grid. The first one being in the wireframe itself, have more circles. So we have to increase this resolution from 50 to maybe something like 100. And that'll double the number of circles that are coming around over here. The next thing is that we definitely require more and larger cubes. So we can go down here and just increase the density to something like 50, and we can just increase the max value to something like 0.25. Now we can just switch off overlays to see what it looks like, and that's fine for now, but maybe we can keep the max value at 0.2 so that a bit more of the wireframe is actually shown. Now we want to actually animate the camera. So in order to animate the camera, let's just go ahead and hide the cube for now and switch on overlays. Let's take the Bezier circle, increase the resolution all the way to 128, and then on frame number 0, select our empty, go to object constraints and tap I over the offset. Then let's go to the last frame, which is going to be frame number 300, and then just go to the offset, type 100 and hit I. Then we can hit T with our cursor at the timeline and change the interpolation to linear. So now when you play it, the camera should form a nice loop around our Bezier circle. The animation is going a bit too slow, so we can set all of our animation defaults by going to the output properties, changing the frame rate to 30, and while we're at it, changing the output folder to wherever we save it by hitting /, changing the file format to FFmpeg video, change the encoding to MPEG-4, and the output quality to perceptually lossless. We can also go to our render properties, switch on ambient occlusion, bloom, screen space reflections, motion blur, and we can change the motion blur shutter down to something like 0.1, and also enable volumetrics and change the tile size to 4 pixels. We will be using these settings a bit later. Now let's switch our cube back on, hit 0 to see what the camera sees, and let's view our animation. Right now, you can see that the frame rate has dropped significantly. So what we can do is go to playback and change it to frame dropping, just so that we see the actual speed. And in case it's too large or too fast, we can slow it down by increasing the end frame of the render. For now, I think this is fine. The next thing that we have to do is actually rotate the camera. So in order to do that, we'll increase our timeline a little bit. Go to frame 40 for now. Select our camera, hit I, rotation. Then let's go 60 frames down to frame 100 and then just rotate it by -90 degrees, hit I, rotation, then go to another 60 frames, so 160, and then rotate it back to what it was. So let's take this keyframe, just shift D and just place it here at 160, and then let's go to 220, which is another 60 frames, then rotate it by 90 degrees this time, hit I, rotation, and finally 280 will put it back to how it was. So just select the original keyframe, shift D, and place it at frame 280. So now when we actually play the animation, you should see the camera rotate and then rotate all the way to the other side and then rotate back. So right now it's set at Bezier and I want it to remain at Bezier itself, but just to make sure, T, Bezier. So that'll actually smoothen this entire animation out a bit. So now the next thing that we can do is actually change the perceived speed by changing the field of view of the camera. So maybe 20 frames before 100, so around frame 80, we can go to our camera properties and on the focal length, we can just hit I, and then by the time we reach frame 100, we can go ahead and decrease the focal length to 10 and then hit I. After that, we can go down to 220, hit I on the focal length, and then go 20 frames later, so 240, and just bring the focal length back to 18 and hit I. So now when we actually watch the animation, you'll notice that the animation starts off a bit slow. When it rotates, it seems like it's going a lot faster, and then once it finishes this set, it seems like it's slowing down again. That's simply because the field of view is increasing. So we can just reduce this a bit, and there you'll actually see it happen. If at all you feel like the entire animation is happening a bit too fast, another way in which you can change it is by selecting your geometry node, just going down here and reducing the actual scale or radius of the initial curve. So instead of having it at 10 meters, we could change it to 5 meters. When you change this to 5 meters, you'll have to actually take this down and scale it by 0.5 as well. So now when you take a look at it, you'll realize that it looks like it's going a lot slower because it's actually covering a much smaller angular distance. But that's currently what the animation looks like. Now you can see how it's speeding up in the middle, or at least appearing to speed up and slow down. You can exaggerate the effect by exaggerating the FOV as well of the camera. So you can go to the camera, and if you actually decrease the focal length even more, it'll seem like it's going even faster. Once we're done with this, we need one more area in the geometry node. So let's go ahead and create that really quickly. So let's reduce our timeline back and increase our geometry node editor over here, and just go ahead and place a frame around this as well. So let's select these, Ctrl J, and label it as cubes. Now we're going to search for another curve. So let's search for a curve circle, place it down over here, change the radius to 5 itself for now, and just search for a curve to mesh, and then place the curve into the curve, duplicate it, Shift D, and place this curve into the profile curve, and reduce the radius of this to something really small like 0.05, and then take this mesh and just plug it into the joint geometry. So now you can see that it's right in front of our face. We don't want it to be there. So what we're going to do is we're just going to change this radius and just make it something slightly smaller so that it moves towards the side. So in this case, let's go with 4.5 and just see where it is. Now the next thing is we don't want it to be directly next to our view. We want it to be a bit lower. So we're going to search for a set position node, and we're going to place it right after the curve to mesh, and the offset on the Z, we're just going to decrease it by a little bit so that it goes down over here. Now we can change the radius to something even smaller. Let's say 0.025, and we're going to have to increase the resolution to something really high. Let's go with 128. Now we need to duplicate this. So in order to do that, we're going to select all of these, Shift D, place it down here. And now we're going to go ahead and just increase the radius this time. So let's increase it to something like 5.5, although we might have to change it later. And to actually see it, we could just connect this to the joint geometry. But to keep everything within a frame, we're going to join the geometry right over here. So by adding in another joint geometry node and just connecting these up like that. So then we can increase the set position offset to plus 0.35 this time so that it goes up. And now we can actually play the animation and see where these two lines are. Now this is looking perfectly all right for what I want them to be. But what we have to do is add in materials for everything right now. So before we do that, let's just place all of these into their own frame, Ctrl J, and call this as inner lines. Now let's give each of these their own materials. So since this is in geometry node, we have to assign materials for each of these separately. So let's go to the materials tab. We already have one material. We'll call this wireframe, and we'll just add in 2 more material slots by clicking this plus twice and then clicking new, changing this name to cubes, and then selecting this slot, adding a new material and calling it inner lines. Now we can go ahead and just Shift A, search for a set material node and place it right over here, and Shift D, place it here, Shift D, place it here. And we're going to give this one the wireframe material, this one the cubes material, and of course we're going to give this one the inner lines material. Now we can go ahead and start with the actual shading. So let's go to our shader editor over here, and we see that we're currently working with the inner lines. So we'll just switch to the rendered viewport shading so that we can see what we're doing. The first thing that I want to do is go to the world tab and just change the color down to black, and also delete this light from our scene so everything is black. Now let's select our cube again and go ahead and give the inner lines their material. We're going to delete the principal BSDF. We're going to search for an emission texture and place the emission into the surface. We're going to bump up the strength to something like 40, but we also don't want the entire line to be lit up. We want to give it some character, so we're going to search for a layer weight node and a color ramp, and we're going to just plug in the facing of the layer weight node into the factor of the color ramp and place the color into the color of the emission. Now we're going to change the emission color to a nice bluish color, and we're going to of course bring this in so that we get the actual character for these lines. Now those are our inner lines. Now let's go ahead and work with our cubes. For our cubes, we're going to go ahead and just increase the metallicness quite a bit. And for the roughness, we're going to search for a Voronoi texture and play around with the roughness. But in order to see it properly, we'll just switch off our overlays and then take the color, pass it through a color ramp, and plug the output of the color ramp into the roughness of the principal BSDF. Now, of course, we can go ahead and keep this as is, or we could change this to Chebyshev, Manhattan, play around with what you feel like, reduce the scale if required, and so on. And in case you feel like people are going to notice that all of the cubes are going in the exact same way and the pattern is repeating, although it's not really that easy to tell, if you still feel like it's going to be told, you can always switch on Node Wrangler and hit Ctrl T, or alternatively add in the mapping and texture coordinate nodes by yourself and change from generated to object. And then once you're on object, you can go ahead and just search for an object info node and then take the random value, pass it through a math node set to multiply, just set it to multiply, and then take the random or the location it doesn't quite matter. So what we'll do is we'll take the location itself, plug it in here, multiply it by 5 or a larger number, let's go with 10, and just place this value into the location socket over here. So now it's going to be fairly random. You can always play around with the scale till you get something that you like. And in my case, I'm just going to crunch in the color ramp a little bit to bring out a little bit more contrast. And as usual, I'm going to reduce the white so that it's not completely rough in any situation. And I'm going to increase the black so that it's not completely reflective in any region. The next thing is the emission. We want a few of the cubes to be lit up. In order to do that, we're going to search for a noise texture. We're going to duplicate the mapping node and plug the vector into the vector of the noise texture. We're going to search for a color ramp to help us select which cubes we want lit up. We're going to reduce the black in quite a bit and change the color to the color that we want it to light up. So we want it to light up to this nice blue color. So we're going to place this color into the emission. Now the thing is, right now, all of them are going to get it based on the noise texture, but we want only certain objects to actually light up. So in order to do that, we're going to take the random value of this object info and plug that into the vector. As soon as we do that, we'll notice that random ones are supposedly lit. We can choose the number that are lit up by playing around with this color ramp. So let's assume that these are the ones that I want. We'll have to increase the emission strength to something like 50 so that we can actually see them. And there we go. In case you feel like either none or too many are being selected, you can actually go ahead and play with the scale of the noise texture. Let's increase it to like 10 and you'll see that we get a different selection of cubes to be lit up. So once we have that, we can go ahead with our final thing, which is adding volumetrics. So in order to add in volumetrics, we're going to add in a new cube. So we're going to go here, just switch on overlays again, Shift A, Mesh, Cube, and just scale the cube up until everything is covered. Once we have that, we can add in a new material and just delete the principled BSDF and search for a principled volume node and plug the volume into the volume socket. Now the problem is that right now everything is lit by screen space reflections and volumes are not lit by screen space reflections. We need physical lights to actually be there. So we're going to go ahead and add in those physical lights as soon as we finish with the principled volume. We know that we're going to be searching for a noise texture and a color ramp to control the density of the principled volume. So let's take this color, plug it into the factor, and place this color into the density. And now let's just go to 7, which is our top view, and Shift a light, make sure that it's a point light. Go to the light settings, and here, because we don't want this light to affect the actual inner lighting that we've already done, we're going to have to go ahead and switch off diffuse and switch off specular. Change the color to this bluish color and increase the power to something like 1000 or 100. Now let's take the light grabbed on the x-axis and just move it to about there and just duplicate it so that we have 4 lights, which should be enough around the entire scene. So there we go. Once we have all of them placed, we can go back to our camera view and see what it currently looks like. Right now, the volumetrics is way too much. So let's just select our volumetrics cube again. We can actually label this as volumetric cube and just crunch in the black a bit. And if you don't see anything, increase the scale, maybe something like 10, and just play around with this until you get something that you like. Now you can switch off overlays and see this. Just before rendering, another thing that we have to do is give the material of the wireframe. So let's go to the wireframe material. And for this one, we're just going to delete the principled BSDF. We're going to search for a glossy BSDF and just plug that into the surface and go ahead and reduce the roughness by quite a bit. Maybe keep it at 0.2 and just make sure that it is as white as it can possibly be. With that, we have the material for our wireframe set as well so that it can be seen. And lastly, because we added in motion blur, you can go to some situation like this and just render out one particular image so that you can test whether the actual motion blur is too much, too little, whether at all it's required for your scene and what you think the scene should actually look like. Another thing that you could also check is how long it takes for each frame to actually render with all of the settings. And this is what it looks like with motion blur. I think it looks perfectly fine. It took me 19 seconds for this single frame. That's probably going to be much faster on your laptops. Mine is fairly low end. So I feel like even the volumetrics is working fine at the resolution of the tile size that I selected. So I'm happy with these settings and I can just go ahead and render the animation. Hopefully you learned some tips and tricks from this particular video and you can apply them in different areas to create innumerable different animations. If you have any questions or queries, do comment them down below and I'll definitely try and answer them, or else create videos to explain and clear off as many doubts as I possibly can. And until then, don't forget to stay creative.